Please remember there are additional resources and things such as code samples at eliithecomputerguy.com. So if you're watching one of these classes and you need to know what code looks like, or if you need links to the resources that we're using, please go to eliithecomputerguy.com and take a look at our class posting there. Also, please remember that free to the end user classes are not actually free. It costs me a lot of money to be able to provide this type of content. So if you could click on the donate button and throw in a couple of dollars every month, this will help me be able to continue to provide you this type of material. Welcome back. As you know, I am Eli, the computer guy, and in today's class, we are going to learn how to write and read files with Python. So this may come as a shock when I say this to you, but writing and reading files in Python is very, very, very simple. The basics of how to do this, I'm going to show you in about 5 minutes, and you're going to be like, wow, Python is so easy. And then I'm going to give you a demonstration at the end where basically what we're going to be doing is we're going to be pulling records out of something called a CSV file to print those out into an HTML document, and then you'll start to see where very, very simple starts to become more and more complicated relatively quickly. Again, if you're new in the technology world, what's important to understand is that all of the basic concepts and anything that you're going to learn in technology, everything from TCP/IP to Python or whatever else, the basic concepts are really, really simple. It's when you start layering on lots and lots and lots and lots of basic concepts, that's the point that you get a migraine. So today I'm going to be showing you how to write to files, how to read from files, and then again at the end we're going to do a bit of a demonstration to show you how you can read out of something called a CSV file, a comma separated value file. It's a data store. Basically be able to read data out of one of those files and then output results into an HTML document that you can open up in a web browser, and that'll start to give you an idea of why this is so significant and also how you can use Python in the real world for your own projects. Warning, Will Robinson, warning! You might have issues with permissions. And frankly, we're not going to go into that very much today. So everything that we're going to be doing today should be in your home directory or in your home file structure so that you should have the permissions to be able to write files, to modify files, and to read files because it is your user account's home directory, right? So when we talk about permissions in the Linux world, we have like 777, it's read, write, execute permission. When you go to the Windows world, they have so many permissions. I remember when I learned NTFS permissions, I don't know what it was, 22 years ago, and they had like 6. They had 6 permissions back in the day, something like that. Now, oh my golly, if you open up the permissions list in Windows Active Directory, there are so many permissions that you can configure. The important thing to understand here is at the operating system level, possibly at the network level, that a system administrator can configure who is able to write to a file or write into a folder, who is able to read a file or read files that are in a folder, who's able to execute files, and the whole 9 yards, right? So basically, when we're reading and writing files, the important thing to understand is right now, we're just going to be reading and writing to your home directory or reading and writing to your desktop in one of the labs. But you could be writing to a web server. So when we dynamically create an HTML document, you could basically be saving that directly into a web server so that your employees or so outside users are able to access that report that's been created from just simply a URL address, right? In Python, that is incredibly simple. The question may come up, do you or does your account or does your system or whatever else have permission to write into the folder on that web server? That's one of the places that you might run into a problem. And so if that's the kind of thing that you're going to do, you're probably going to have to learn a little bit more about permissions. So this is just something I'm just giving you a heads up on, because again, remember, especially in the programming world, most people do not fail at learning to program. They give up, right? They sit there, they tippy tap out their code, it doesn't work. They then modify their code, they keep modifying their code. They spend 2 days re-editing like 10 lines of code trying to figure out what the problem is. And what they don't realize is they literally do not have permission to write into the folder folder that they're trying to write into, and then they say, oh, I'm a horrible programmer, I can never do this, and then they give up because they don't realize the issue that they're running into has to do with something that they may possibly not understand at this point. So when they're reading or writing the files, it's important that the user account that is running the script, that actually is running the script, has permission to do whatever it is that you want it to do. Again, for today, to home directory or desktop, you should be absolutely fine. There should be no issues. But when you start automating these scripts, that's when you may run into permissions problems. And I have lots and lots of Linux classes, and I have lots of Active Directory classes. And I don't know, maybe you need to go to ChatGPT and say, hey, what permission do I need to give for this script to be able to run properly? Just kind of one of those things to be thinking about, but it can cause you a real problem. So now I'm going to show you how to write to a file using Python. There are two different ways you're able to write to a Python, and literally if you can understand 5 lines of code, it should be simple for you. Python will be easy. Anyways, the first way to basically be able to write to a file, what we're going to do is we're going to have a variable. So the variable is going to equal the open function, and then the name of the file that we're going to be opening, and then the mode we are going to be opening the file in, right? So basically we're going to open test.txt with W, which stands for overwrite. So what overwrite is going to do, W is going to do, is if the file does not exist, it will create the file. And if the file already exists, it will delete the previous version of the file and then write everything into the new file that is created. So W can be very useful in some circumstances, but just realize if you use W, you will delete all the data you had previously put into a file before you write the new information. Then what you're going to do is you're going to do file.write, so file, so whatever that name is, file.write, parentheses, and then whatever you're going to put in here. So you could put a variable in there, so the variable value gets written into the document, or you can put text, so single quotation mark, hello from first example, close single quotation mark, and then we're going to do file.close. So this is very important in this first way of doing it. If you do not close the file once you've opened it, doing it this way, you may run into a lot of what we like to call in the tech world quirky problems. Quirky problems, right? There are hard fails and then there are soft fails. So hard fails is where your script fails and it doesn't function. And soft fails, like your script ran, but it did something kind of weird, right? And that's what we're going to get here if you don't actually close the file, you might get some weird problems. So if you forget to put parentheses at the end for file.close, that's not actually the command. So that may cause you problems. If you forget to close, that might cause you problems. If you're doing this whole file write routine and something fails out in here so that you don't get to the file close part, that might run you into some problems. So that's one of the issues with this method for basically opening a file and writing to it, is you need to make sure that you close the file. So that's where down here we have the second version is with open test2.txt, W for overwrite as file2. So we're going to do with the open function, open test2.txt with overwrite as file2. Then we're simply going to say file2.write, whatever text or the variable that we're going to put in there. And then the nice part about this is it automatically closes the writing operation or the reading operation or whatever else as soon as it's done. So it does this and then it closes. So you'll notice we have a colon here, right? Just like we would have with an if-else statement or a loop or something like that. And then this gets indented. So this is acted as the same way. So basically we're going with open as file2, we're going to open, we're going to do something. And then once we get to the end of whatever lines of code we have here, it will automatically close the file. So this is generally considered the better way to do things. So if I go over and I look at my home directory right now, we can see I just have folders in my home directory and a data.txt file we're going to use later. I have nothing else here. So what I'm going to do is I'm going to go and I'm going to run this script,
right? We get no response back because I'm not printing anything out to the console screen. We are then going to go back, and now we see test.txt and test2.txt. I open test.txt, and we can see, hello from first example. Woo! And we can see, oops, nope, damn it. And we can go to test2.txt, and if we increase the size of that, we can see hello from the second example. And so that's how you're very easily able to write text into documents.
Now, when we're writing to files, we need to think about the formatting that will be required for whatever program the end user is going to be using to access the data that we're writing, right? So if somebody is simply using something like Notepad or TextEdit, that's an ASCII text editor, so you would use ASCII formatting in order to format the text. If you are going to be outputting to a web page, so an HTML document, you would be using HTML tags. You may also use CSS tags. You may add in a JavaScript and the whole 9 yards. But remember, an HTML document at the end of the day is simply a text document that has this HTML formatting around it with possibly CSS and HTML and other things. If you're dealing with an XML document, when you're outputting, you're going to need to format for XML for whatever it is that you're doing. And so this is one of those things that you have to consider when you're going to be outputting the data. What application do you expect your users to be using to interact with the data? So if you encode everything for HTML and they open up in a text editor, it's going to be a disaster. And if you code everything for ASCII and they open it up in a web browser, it's also probably going to be a disaster. So it's kind of just one of those things that you need to think about. But the cool part in Python is it's really simple because basically you can just add in whatever tags or add in whatever formatting that you need. So with this particular thing, we're going to create a little web page called web.html. So .html, this is the extension, so whenever this is seen on any modern computer, they will automatically try to open it with whatever your default web browser is. So for me, it's going to open up in Safari. For you, Firefox, Chrome, or Edge, or whatever the hell it is that you use, right? So this is going to be creating a web page. Now, the important thing to understand here, again, especially if you're new in the technology world, is that this is a real web page. I mean, it's a crappy real web page, but it's still a real web page. If I wanted to output this directly onto a web server that was sitting up on the internet, I could do that, and I could have millions of people accessing this web page as soon as I publish it, right? Basically, how something goes from being like a web document, something that's simply on your computer, to being what you consider a web page is simply whether or not you put it on a web server that has internet access, that type of thing. So anyways, with this, we're going to create a message. So message equals, and so in order, if you're going to do like multi-line like strings, so this is very useful. Again, if you're going to be outputting and you're going to be outputting into HTML or XML or something like that. Sometimes you need to put a lot of text and you still want it formatted decently so you can figure out what the hell is going on. So you can do a basically single quotation, or single quotation, or double quotation, double quotation, and then close it at the end. And this allows you to do multi-line strings. Then all we're going to do is we're going to do H1. We're going to say title. So title is going to be in the H1 tag. We're going to do a P tag. This is a website. We're going to close a P tag, open a P tag, do style. And then again, remember where I told you before about the single quotation versus the double quotation, deciding what you want to do. In Python, it doesn't matter whether you use single or double, but you need to mix it up if you're going to be doing something like writing to a document. So since I have single quotation marks here, when I do style equals, this has to be a double quotation mark. If I have single quotation marks here and I put a single quotation mark here, the script will fail, right? Because it's like, okay, this is where it opens. If there's a single quotation mark there, it'll think, oh, that's where it's going to close. So you might run into a problem there. So anyways, double quotation mark, color, :red. So this is CSS. Isn't it cool? And did I lose the NP tag? Somehow lost the NP tag. Let me put the P tag there, do a Control S. So that is what's going to be printed out to this web page. Then we're going to do what I showed you before with open web.html now.
W for overwrite as file2 message. So into file2, we're going to write this HTML data, and we will get a web page. So I run. I don't get anything at the end because I didn't tell it to put anything out. You will now see I get web.html up here. I can double click. Woo! Isn't it pretty? No, it's not. Don't lie. Don't lie. It's not pretty, but it proves the point, right? Title in H1. This is a website. Normal p tag. Isn't it cool in red? So that is how we are able to use Python to be able to dynamically create a web page. And literally all it is writing to a text file, simply using HTML tags and CSS formatting, and then saving that file as a .html versus a .txt. So what I just showed you was how to do HTML formatting. Now, many times you're going to be dealing with basic ASCII formatting. So ASCII for text formatting is like when I print things out down on the console screen down here, that's ASCII text formatting. Again, when you open up something in Notepad or text edit or something like that, that is going to be ASCII text formatting, and there's not a lot to it, at least that most of us use. Basically, there's generally the T for tab or the N for next line. So up here, we're going to have a message like we had before. So message is going to equal, we're going to open a single quotation mark, and this is just going to be ugly. Like when I show it to you on the screen, you're like, wow, that's ugly. Yes, it's ugly, but it proves a point. And then you do /t. So /t means tab. Is /t tab a way to /t tab format /n for next line, and then text will be on the next line. So basically we're just going to get some words with some random tabs in the middle, and then we're going to get a next line, and that kind of shows you how the tabs in the next line works. Where this really works out for you is when you're formatting like data to output to the console screen, and you want things to line up. Let's say you're reading from a file, you're reading from a CSV file, so that data store of records, and then you want to be able to print records out on the screen. So you can do person's name, tab, age, tab, shirt size, next line, next person's name, tab, age, tab, shirt size, next line, next person's name. That's kind of how you would do this normally. And again, we'll get into a lot of that as we continue with this whole Python series. As we did before with open, text.txt, W for overwrite as file.write the message, and when I run this, we get no response because we didn't print anything up here to respond. And we can now see we have text.txt up here. And when I open this up, we can see our less than ugly formatting. Oops. So basically with this, so that you can see it, so this tab is tab, a way to tab, format, next line, text. And so again, that's basically how you can do the /t and the /n to give yourself tabs or to give yourself next lines when you're going to be outputting to some kind of ASCII text type format. So now that you understand how to write to a file and the basics of text formatting when you do, now we need to learn how to be able to read from a file. And basically, again, it's very, very simple. We have the two different types of ways of interacting with a file, just like we did before. So we have the file where we open and the file close, and then we can also do the with open as file and do whatever it is that we're going to do. Again, this first version is a way to do it, but you do have to close the file or you'll run into problems. Using with open, the good part about this is as soon as the commands finish, it will automatically close the file for you. So honestly, this is probably the better way to go. So previously, we have already created two TXT files in our very first lab, test.txt and test2.txt. So we are going to be reading those documents, taking the information from those documents and assigning it as the value of a string for message, and then we're going to be printing out that value. So file equals open, test.txt, mode of R for read, message equals file.read. So this file that we opened, we're going to read that file, and then all the text is then now going to be the value for the variable of message. We're then going to close, because we need to close the file, and then we are going to print out the message, and so we got the message that we put in previously. With this, with the open, so we can do with open test2.txt, R for mode, read as file2, message2 equals file2.read. So whatever is in here, this will be assigned the value for message2, and then we're going to be printing out message2. Now, in a couple lessons down the pike, I'm going to talk a little bit more about file paths and how you can determine where to read from files or where to write files in your file structure when you're dealing with Python. But if all you're doing is saying read a file or write a file like we did before, then basically what's going to happen is this is going to be read and read by default into your home directory, right? So I'm using Mac OS right now. So my home directory is under Eli. So there's root, users, Eli. Eli is the home directory. So you can see desktop downloads, documents, right? This is the root directory for my user, which is called the home directory. So by default, that is where all the documents will be written to. And by default, unless you specify someplace else, that is where the files have to be for you to be able to read the files, right? So we have test.txt here and test2.txt. Because these are in my home directory, when I go to read, I can simply call them as test.txt and test2.txt. Again, we're going to talk a little bit more about file paths in a couple of minutes. But from here, all I need to do is I need to click the run button as we do, and we can see hello from first example and hello from the second example. And so that is how you are able to read from text documents, take whatever text is in a document and save it as a string data type into a variable, and then you're able to interact with it. It is important to understand when you use the file.read, it's going to take all the text that is in that document and it's going to save it as a string data type. So even if you have a CSV file, right? We talked about that before with spreadsheets or whatever else, comma separated value file or a tab separated value file or whatever else. Even though when you import it, if you print it out, it looks kind of sort of like a list. It's not actually a list, it's a string. So that's one of those things that you might run into problems with. And again, we'll explain that a little bit with our final demonstration at the end of this particular class. So now let's take a moment to talk about file modes. So when we were opening those files and whether we were writing to them or reading to them, we had to specify what mode we were using in order to interact with that file. So we used W overwrite and we used R before, but there are a few other modes that you need to be thinking about. So W is overwrite. If the file does not exist, it will create the file. If it does exist, it will delete whatever is currently in the file and overwrite it with the new information. Then you have append. So append, A, is append to end of file. So you have a file and they're just going to add to the end of it. So think about A as used a lot for things like log files, right? You have a script. It's going along. Every time it finishes a routine, it appends some log file to tell you what's occurring. Or maybe you have something like a CRM solution where you're going to add notes at the end of the file, that type of thing. This will add to the end of the file. Then you have A+. Basically, this is append or create file if it does not yet exist. So with A, if you have A, and it goes to open a file, and the file does not exist, then the script will fail. You'll get a fail. With A+, if the file does not exist, it will create the file for you. You then have R for simply read, and then R+ for read or create the file if it doesn't exist. So the file doesn't exist, it will create it, and then it will simply read the blank value because there's nothing in there yet, and that will go into your script. RB is for read in bytes, and WB is write in bytes. And what this is for is multimedia files. So with Python, you can interact with images, video files, audio files. We're going to be doing a lot of classes with machine vision and machine speech and that type of thing. And when you're dealing with those types of files, basically you're going to write to them and read to them with RB or WB. And again, that's something I'll show you later. It's not necessarily that that's complicated, but it kind of gets specific when you start dealing with multimedia files. Now, when we start dealing with file modes, this might be one of those things that you look at and you go, wow, that's simple. That's easy. I understand. But again, one of the things that you need to be thinking about as a real technology professional is when is it appropriate to use things like A versus A plus or R versus R plus. So where A plus and R plus can be very useful is when you initially set up a script on a server, right? So imagine you have a script and it runs and it's going to be appending to a file that already exists. Well, here's the thing. What happens the first time you run that script? The very first time you run that script. That log file may not currently exist because it hasn't been created. Like once it gets created, A will simply append to the end of it. But if it hasn't been created yet, if you use A, it will fail because it does not yet exist. So you might use A plus to basically say, if this file doesn't exist, then add to it. Again, with R, let's say you're trying to read from a log file, you're trying to read from some data store, but the first time you run the script, that file does not yet exist. So you might do R plus. Again, so it'll read if the file doesn't exist, then you'll create the file and read nothing into it. One of the things to think about, though, is again, okay, well, that's why you would do it when you're initially setting up the script, right? So let's do A plus and R plus, because if the file doesn't exist, then it'll create it and it'll solve the problem. Here's an interesting thought for you, though. What if, for some reason, the file that you're supposed to be reading or writing to stops existing every day or two? Let's imagine an intern was given the job of coming up with a garbage collection routine for your server. And let's say the senior programmer, the senior developer that's supposed to be overseeing the intern is having a whole bunch of problems with their marriage and their kids on drugs and a whole bunch of other things. And so the intern showed him the code. The senior developer went, yeah, fine, that looks fine, go deploy it. And so now you have a garbage routine going on your server, and every couple of days, whenever this garbage routine fires, the files that you depend on for your script are simply deleted. Well, here's an interesting thing to think about with the difference between hard fails and soft fails, right? So if initially I simply used A or I simply used R, and then I use something called the touch command. So the touch command allows you to just create a file, just create a blank file. So I add my script to the server, I do the touch command to create these blank files, and then I use A or R, right? Well then, if the files that I'm supposed to be interacting with get deleted, they're no longer there for some reason, I will get a hard fail. My script will fail. And hopefully you're paying attention to what's going on, and so you will see it hard fail so that you know there's an issue, right? So basically you do touch, you create the files, you're reading or writing to them. 2 days later, your script hard fails. You're like, what the hell? And then you go back and the files are gone. Yeah, that's weird. So you recreate the files and let the script run. You watch it run a couple of times. You're like, okay, that's fine. Then you go away, like 2 days later, your script fails, and you go back, what the hell? And then you go back, and the files are gone. And you're like, and you're gonna go through, and you're gonna look through your script. You're gonna look at your script. You're gonna see anything that maybe in the if-else statements there's a weird thing. This is frustrating. And so you're gonna do what most tech people do. You're like, I don't understand. So you recreate the files, and you have the script running. It seems like it's going 2 days later. Your files get wiped out again. And then you start seeing the geek go all aspy on you. Full metal aspy. What's happening to my files? And then the manager is going to come over to the team lead, is going to figure out what the hell's going on with the poor little Aspie, and they'll go through and they'll figure out. Well, wait a minute. So you have these files, you created them 3 different times. They'll audit your script. They'll make sure your script isn't doing something stupid. And they're going to be like, well, wait a minute. Yeah, why do these files keep getting deleted? And so then they're going to start asking around the office, is somebody doing something stupid with the server? And the intern will be like, well, I just created a garbage collection routine. Oh, and then the team lead is just going to sigh. Like, can I see your code for a second? Oh, yep. See? Every 2 days, his code deletes files with your names for some reason. How did this get through the auditing process? Quality control? Anyways, right? But you have a hard failure. It may suck to figure out what the problem is, but you know that there's a problem, you know that there's a failure, and therefore you can go and try to fix it. One of the problems, if you're going to use R plus or A plus, right, it will recreate the file. So let's say you're writing to a file or you're reading from a file for 2 days, and then the file gets deleted, but then your script auto recreates the file. And so now it reads in blank. It's like it's obviously a brand new file, right? And then 2 days later, the file gets deleted, but your thing recreates, right? What happens if you have something like notifications that are supposed to get triggered based off of some occurrence of events, right? If CPU utilization on 5 servers goes above 70% for X amount of times, then I get an email. Well, here's the thing. Your script is going to go read, but the thing is, right, if that file keeps getting deleted every 2 days, then at any one time, your file may only have 3 occurrences of the CPU going over a certain amount, and it will never get to 4 or 5 or 6 occurrences because every time it goes above that threshold, the file keeps getting deleted, so therefore you do not have that historical data. Now, here's the thing. If your script is not failing, it is not completely failing, it is working, it's just not working properly, how long will it take you to know that there's a problem? Right? If you have a script, a routine that is occurring that is supposed to notify you when there is a failure with your infrastructure, and you never get an email from that routine, do you think that there's a failure of your script, or do you think your infrastructure is just working fine? And again, if you're most geeks, you're going to be like, yep, that's my infrastructure. Of course my infrastructure is perfect. There could not possibly be a problem with my script or some kind of garbage collection routine, right? And so an issue like that, right? Imagine if you're supposed to be scanning for things like failed backups or something like that. If a file gets deleted and then recreated, you do the append or read, like it might be months and months and months until you realize there's a problem. Again, in the real world, I've seen back in the day when we, goddamn, when we had to do backups, like real backup. I saw, again, because I had to deal with 10, 12 offices back in the day, and I saw where the previous administrator had screwed up the notifications. So even though backups were failing, I was supposed to get a notification to know that the backups were failing. I never got the notification. I was brand new to the job, and the other guy seemed like he knew what the hell he was doing. So I thought all the backups were working wonderfully. I would go to offices and find out backups had not functioned properly for 5 months because I had never gotten notified that they had failed. And so this is that kind of thing that you need to be thinking about. Again, on that simple level, do you use A or A plus? Do you use R or R plus? It's not just about what will allow the script to run easiest the first time, but also, going into the future, will you get the hard fails that you need? So now let's take a moment to talk about file paths so that you can read and write files not necessarily in your home directory, right? So here I've created the file-path.py script, and it's sitting on my desktop. So I've created the script on the desktop. So I'd really prefer simply output the text file to the desktop, or be able to read files from the desktop because that's where I am. By default, everything is going to go to your home directory for whatever user account home directory is. That's where we're going to go by default. And that's going to get ugly after a little bit, right? As you start doing labs, as you start doing projects, you'd rather create one folder and then simply be able to create your scripts in that folder and then have the input and output simply in that folder. You're not going to want to gunk up your home directory like you will notice that I do most of the time. I mean, look at this. I've only done a couple of labs today and already I'm starting to get more and more text files in there, right? And so basically what we're able to do is we're actually able to change either the file path or the working directory we'll talk about in the next lesson. So with this, just to show you as an example, so don't worry about the OS module yet. So file equals open test3.txt w for overwrite. So basically, if test3.txt doesn't exist, we're going to create it with w. File.write hello from the path example and file.close. Now again, this script is sitting on my desktop. It's not sitting in my home directory. So when I run this, what I would like to see is that the output would show up on my desktop. It didn't. What we can see up here is test3.txt. It showed up in my home directory. And when I double click on it, I can see the hello from the path example. That's not really what I want to have happen. So if we go down here, we can take a look at the way to change it. So I'm using these quotation mark, quotation mark, quotation mark things again. So I'm going to cut that out. And then let's see here. We're just going to go down here, print this so we can talk about these things. So here we have some commands. So we have OS, right? So import OS. This is the OS module. So what we're going to do is we're going to come down here and we're going to say print os.get current working directory. So what is the current working directory? Then we're going to print, this is how we get the path of our current file. So file here means this file, this script. So os.path.directory name, parenthesis, os.path.real path of the file. So you have to put this whole mess in there basically to get the real path. Again, there's a difference between a string and a real path. So you don't actually have to put all that text in there to get the string. But then if you just have the string, that's not necessarily formatted properly for a path. It gets a little wonky. So that's why you use all this. So this right here, this whole ugly thing here, this is going to be getting what's called the real path of the file of this script so that you can use it later. So here we're going to have directory. So directory equals os.path, this same thing, and then we're going to print out that directory. So directory is now going to be a variable with the value of what our path is. We're going to print that out. Then down here, we're going to create file path, and we're going to use join. So file path equals os.path.join directory. So this is the file path where we currently are, the real path where we currently are, with test4.txt. Now again, you might be looking at this going, why are we using join? Why don't we just use an F string or something to concatenate the directory path with the file? The reason that we use join is join basically formats this path based off of whatever operating system that you're using. Whether your operating system uses forward slashes or backslashes or some other differentiator for files, this join will actually use those for your operating system, right? So that what this does is this makes your script be able to be moved from a Mac OS to a Windows computer to a Linux computer, and whatever the formatting for that computer is, it will automatically be used here. So if you use some kind of concatenation here, like an F string, and you put in forward slashes or backslashes, that may work on one operating system but won't work on a different operating system. And we're going to simply print the full file path. So we're going to get the current working directory. So again, that's going to be my home directory generally. Then we're going to get the file path to where this file is. We're going to assign the file path to the variable directory. We're going to print that out. We are then going to create a full file path with the directory and the new file name. And then we're going to print that out. So when we do this, It's so sexy. It's like, woo! Wow, Eli, we got text. Yay, text. So get current working directory is users Eli. Real path of this file is users Eli desktop. Directory is set to that real path. Print out that directory, so users Eli desktop. And then file path equals join the directory to the new file name, test4.txt. So it'll now be users Eli desktop test4.txt. And so that is where the file will now be saved. If I get rid of this commenting here, again, we have all this stuff before. So file equals open file path. So that's the directory with the file name, W for overwrite, file.write, hello from new file path, file.close. Then let me do Control S, make sure I get saved. Then I will run this. So again, notice no additional files right now. And then I'm going to run this. It runs, it doesn't give me a response because it doesn't need to. And now we can see test4.txt is on the desktop. I'm going to double click this and then, yeah. Hello from the new file path. And so that's how you can have your script either read from files in the current directory or write to files in the current directory. And again, this is kind of one of those things you just copy and paste. Unless you're really going to remember that. Like this is what you do. os.path, directory name, parentheses, os path, real path, file. That is the command that you're always going to use. If you can remember that, good for you. I have it in a little note so I can just copy and paste it and dump it into my script, right? And then also, if you need to know what the current working directory is, because this might get changed, right? If you're going into a legacy system, so again, some kind of server that's been through 5 or 10 hands before you, somebody may have changed the working directory. So again, when you go to read or when you go to write, it might not be working the way you think it is. os.get current working directory, CWD, you can print that out to see what the current working directory is, to verify everything is configured the way that you think it's supposed to be configured. So we were talking about the current working directory. So the current working directory is the root, the location that your Python script is going to be automatically writing files to or reading files from. You can change that on a per script basis. And so basically with that, you can do an os.chdr to whatever your new directory is. So again, imagine that you have a script. And so let's say all of your scripts are in one folder, but then they're going to output log files, and you want those log files to be in different folders, right? So your script, every minute, it's going to scan the network or do something, and then it's going to create a new text file in some specific folder, and that's where all the log files are going to be, right? So the scripts are here, log files are in their own folders. Again, something to be thinking about as a real technology professional is how do you design the structure so somebody can understand what the hell is going on? If all of your scripts and log files are dumped into the same folder, and I come behind you and open up that folder and all I see are 5,000, files, that is not going to be a happy day for me. So I can change the working directory on a per script basis. Import OS, I'm going to import the OS module. I'm going to print os.get the current working directory. So what is the current working directory right now? I'm going to create a new directory, so new directory variable. I'm simply going to set this to root. I don't know what else to set it to, so I'm just going to set it to root. And then I'm going to say os.change directory to the new directory, so it's going to get changed to root. So again, this could go to users, Eli, desktop, I don't know. It could be some long-ass location. And then we're simply going to print out os.get what the current working directory is. So with this, right, current working directory before I started the script was users Eli, os change directory, changed it to root. I now get the current working directory, and now you can see that it is simply at root. So I could start this at the beginning of my script and then basically simply have everything dump into a particular folder or whatever else. Whether you're going to use the path option or the current working directory option, there's decisions to be made on that. We might get that into different classes, but I just wanted to show you this just to show you that this is a different option. So now that we've gotten basically to the end of this class, I want to go over an actual project that would simulate a solution for you. And honestly, depending on what you're doing in the real world, this might actually solve some problems, right? So we have this data store, and in this data store, we have students for a school, right? So we have a student named of Bob, age of 12, large boy. Student Sue, 33, small girl. Fred, 47, medium shirt size boy, so on and so forth. So imagine that this is a school or some kind of membership organization. You're taking the people's name, you're taking their age, you're taking their shirt size, and you're taking their gender, and you're dumping it into a data store so that you can process it or be able to pull out reports. And now do remember, in the real world, when you're doing things in a production environment, you're most likely going to be using a database as a data store. The data store is where you store the data. The best place to do that is generally into a database, Postgres, MySQL, MS SQL, or some kind of cloud service like that. But text files can be very useful when you don't really want to have to set up a server, when security isn't your biggest concern, and especially when you're just dealing with things like log files or whatever else. Just being able to use a text file can make your life a lot easier. Do you remember with text files, right? There is no security. What makes text files so nice to use as a tech professional is you don't have to set up user credentials and connections and all that kind of thing. So you don't have to set up security. But that also means there is basically no security. If a hacker is able to compromise your system, everything that you have stored in this text file, they'll be able to scrape. And so if you have email addresses and all kinds of other stuff, all hell will encompass past that. So anyways, this is what we call a CSV file. This can be useful. You can create CSV files on your own, but also software such as Excel outputs to a CSV file. So you could have somebody create a CSV file with a whole bunch of information, output that CSV, or they can create a spreadsheet with a whole bunch of information. They can output the information to a CSV file, and then you can use Python to interact with it. You can also output from databases. So you could actually use some kind of a select statement for a database and basically output the information into a CSV file so that you can just interact with that data, again, without having to continuously interact with the database. So CSV files are incredibly useful, and you'll see them around quite a bit. You'll also hear of TSV files, not quite as popular, called tab separated values. So basically tabs are the separation. You might also see those. It's just, again, it's just ASCII text formatting as a way to be able to store some data. So anyways, we have this script here, and basically what we're going to be doing at the end of the day is we're going to be creating a web page, which is going to be a report that is going to show us basically certain students. So I have this student list. And again, even with text, you could have thousands. You have thousands of student records in there if you really wanted to. Again, be careful. Be careful in the production environment. It's very easy to corrupt a text file, but you could, right? And so what if you need to go through and you need to pull out all the girls. You need to pull out everybody who's over age of whatever, or, certain shirt sizes, that type of thing. Basically, what this script will do is it'll go through, and initially what we have is if girl is in the record, then we will simply output their name, their information to the report.html, and we're going to output it into a table format. So that is where we're going to get to. But to get there, we've got to do a couple of things, right? So here, we're going to do with open data.txt as read for read mode as file. So we're going to open data.txt, read as file. Again, we're not doing anything with the path here. Data.txt is right there. I'm just leaving it in the home directory. That's what we're going to do today. Then we're going to do file.read. So we're going to read the file, and then whatever text is in that file, we're going to set that as the value for record. So record is now going to be a string. Again, we've talked about data types in the past, different types of data types, ints, floats, strings, obviously, lists, dictionaries, tuples, collections. We'll talk about those later. This is going to be a string, and right now we're simply going to print that string out. So if I go and I run, we can now see, right? So this is data. This is the data.txt file, and so we're outputting this, Bob 12 large, Sue 33 small, so on and so forth. So you might be looking, going, wow, that's easy. We have a list already, right? Doesn't that look like a list? That's index 1, that's index 2, that's index 3. That looks like a list if you don't know what a list is supposed to look like. Right? No, this is a string. This is just simply a string using next lines, and we really can't do a lot with this yet. Right? So what we're going to need to do is we're going to need to turn that into a list so that we can interact with it. I'm then going to do comment that out, uncomment this, and so we're now going to use the split method, what's called the split method, to split that string into a list based off of the next line text formatting value, right? And so again, this is why understanding this stuff is important. So Bob, 12, large boy, next line. So this, right, is signified as /n. Sue, 33, small girl, /n. Fred, 47, medium boy, /n. So what we're going to say is wherever there's a /n, that is where we're going to divide the index. So this will be index 0, this will be index 1, this will be index 2, 3, 4, 5, and 6, right? Based off of /n. Make sure I didn't mess anything up. Yep. So record as we have, dot split method, split the string based off of /n, and now that will be a list, and now we're going to print this out as a list. When I go to print, we can now see we have square brackets. So open a square bracket, close a square bracket, single quotation mark, Bob, 12, large boy, close single quotation mark, comma. Sue, 33, small girl, close single quotation mark, comma. Fred, right? Index 0, index 1, index 2, index 3, index 4. And again, remember with lists, dictionaries, any of these collections, the numbering starts at 0, does not start at 1. So now we have a list. So let me get rid of that. We don't need to print that out next. And let me uncomment this out. And I can explain this little line of code. Or I can try to explain. It's only 9 lines of code, Eli. That's simple to explain. One of the things you're going to need to figure out as a technology professional is just because you can code it, or just because you can do it, can you explain it to the person that writes the checks? Very important. One of the reasons I did pretty well doing technology as a consultant and the rest of it is I could simply sit down with the CEO and I could literally walk them through exactly what I did until their eyes glazed over and they handed me the money. It's like, I can keep torturing you all day. They're like, no, stop. You know what you're talking about. But that really is true. Like one of the big problems we get to in the technology world is, again, it does. It creates a report. It creates a web report. It's a table. Obviously, right? One of the things you need to think about, again, with your peers, with any kind of vested interest in the project that you're doing with your boss, can you explain what you're doing and why? And it can be a little bit difficult. Look, I'm just talking into a camera. I'm like, oh, I don't really want to explain this 9 lines of code. Like, it's obvious. And then I did these 9 lines of code. Go away now. Anyways, let's try to explain this. So with open, so we're using with open report.html. So we're creating a HTML document called report, W for overwrite as report. So this is the variable value we're using for the file, colon. Now everything gets indented, right? So basically why this is useful is once all of this is done, it will automatically close the file and I don't have to worry about screwing something up. Okay, report. So report is now open. We're going to do report.write, and we're going to write in the table tag, right? So again, we're doing HTML formatting. So we need HTML formatting. So this is going to be a table. So we open the table here. My recommendation for you, as soon as you open a tag with HTML, with this kind of Python thing, you go down and you close it. So report.write, open table here. And then on the same line, report.write, close table tag down here. Because if you forget to close a tag, it's all ugly, it's all bad. Okay, for student in record, right? So this is now a list. Each one of these lines is an index in the list, and we are now going to call that student. So Bob is student, Sue is student, Fred is student, Paul, 22 large. And so this is a string. When we say student, this is a string. It's not yet a list or anything else. Right? So for student in record, we're going to go if girl in student, right? So we're going to go take a look at the data. Is girl in student? No. Oh, girl's in student, right? So, okay, so goes girl in student? Nope, keep going. Girl in student, do something. Nope, 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 do something, right? If it sees girl in this string, do something. And then we need to put all of these values then into the boxes on a table, right? So you open a table, then you have table rows. So TR is a table row tag, and then TD is each box. So we have these strings, but we need to separate all these values. So this will be within TD, and this will be within its own TD, and this will be within its own TD, and this will be within its own TD, and this whole thing will be in a table row. So it'll be TR, TD, close TD, open TD, close TD, open TD, close TD, open TD, close TD, close TR, replicate till done or dead, whichever comes first, right? So in order to wrap those values within those TD tags, we need to then split student. So we have student here. So student is currently a string. So if it's a girl, we're going to split the student based off of the comma. So wherever there's a comma, that is now going to be a new index value, and we're going to assign that to value. So student dot split. So take student, we're going to split it. It's now going to be value. Results equal TR for item in value. So this is a list. So we have now turned. So this was a string, and now it's a list. Index 0 for Sue, index 1 for 33, index 2 for small, index 3 for girl. That is now a list. And so what we're going to do is for item in value, right? So for each item, what we're going to do is we're going to basically encapsulate it within TDs. So name, then age, then shirt size, then gender, right? That's going to add on. Here, we're starting result. So result equals TR. So TR is for the table row. We're going to open the table row. Result equals open the table row initially. Then for each item within value, result plus equals means add to, and then set the finished value back to the value for result. So we start with TR, and then we say plus equals. So TR, TD, Sue, close TD. We're going to loop again. So it'll be TR, TD, Sue, TD. Then it'll be TD, 33, close TD. Then it's going to loop again. You're going to have TR, Sue, 33, close TD, open TD, shirt size, close TD. All of that is then going to be your result. Then what we're going to do is to report dot write. We're going to write that entire result. So we opened the table row here. We then created all of the TD, the data items here, and then we're going to write all of that result and close the table row, and then we're going to close the table. So if I then run this, I click run. We don't get anything because we don't need to. Report.html. Now we can see we only have the girls. Sue, 33, small girl. Patty, 20, medium girl. Sally, 15, large girl. And you can see that there's some decent formatting here. Again, you could use CSS or whatever to make this formatting a lot prettier. If we go back and let's say I just wanted the boys, what makes this so nice is if I just want the boys, I can literally just type boy. I can hit save. I can run. I can come back. I can do a refresh. And now it's just the boys, right? And again, imagine if this is thousands of different records. If I want to go back, and for this, again, this is just a very simple script. If I simply want to know who has a large t-shirt size, I can run that, and then we can do refresh, and then we can see Bob, 12, large boy, Sally, 15, large girl, and again, if we're looking for t-shirt sizes or whatever else, That's what we're looking at. So this kind of simulates for you where you can go from having a data store of all of these different records. You can then use a script to go through and pull out the information from those records that you care about. And then you can save that into a report format that, again, your end users, your bosses, any vested interest would actually understand, what to do with. So that's a basic idea of how you can start creating a small application using what we've learned so far in this Python series. Yay! Now we know how to write and read files in Python. We know how to take information from a data store, be able to process it, and then output it into something a user can understand. Or we know how to write into a data store. Again, being able to create your own CSV files and that type of thing. There's two ways to being able to read or write to a file. Again, the file open, and then you do the file close, or you can do with open and basically open the file. Generally, the with open is the better way to do things. Again, in the technology world, there's always 20 ways to skin a cat, and in particular situations, there might be a reason why you would use one way versus another. Again, with the mode seems like a very, very, very simple thing that you would not spend more than a couple of seconds of time on. But when you're designing a product for the end user, it's very important that you think about. Again, W is overwrite, A is append, R is read. But then you got A plus, and then you got R plus. You also got WB and RB for bytes for doing multimedia files. But I really want you thinking about that. Should you really use A plus? Should you really use R plus? Or is it better to use like the touch command first to initially create the file that you're going to be reading and writing from so that you get a hard fail? Remember, in the technology world, I like a good hard fail. I like a good hard fail, and I cannot lie. Here's the thing. It's not really that you like the hard fail, but at least when you get a hard fail, you know that you failed. It's kind of like dating. Thankfully, I haven't had to date for a long time. It's been a long time. I've been with my wife for almost 19 years now. It's a beautiful thing, right? But here's the thing, right? If there's an attractive, whoever you're attracted to, and you say, hey, and they say no, that's painful. Don't get me wrong. That is painful, and it sucks. But you go have a couple of beers and you move on. Who knows? By the end of the night, you're saying hi to somebody else, right? Yes, is it painful? Is it frustrating? But you know what the situation is, and you can move on from it. Versus, right, you say hi to someone, and they're like, they don't really like you, but they're also kind of alone. And so they don't really want to tell you to go away, but they don't necessarily want anything to happen. And so you spend all night talking of this person who's constantly looking for somebody else to talk to. That's just pure misery right there, right? And that's the difference between a hard fail and a soft fail. One, you're told to bugger off, go the hell away, and you know what's going on. The other one, you're like, this doesn't seem right. I don't know. It doesn't really seem like it's working out. But they're not going away either. What do I do with this? Right, that's the difference. Hard fail, soft fail. And so again, like with that A plus, that R plus, do you want a hard fail? You know you failed, so you need to solve a problem. You fix the problem. Or you just kind of get this wishy-washy thing going on. I don't know, Stone. That was one of the things to consider. At the end, I showed you the example with, again, being able to pull out a text file. So being able to pull out a text file, you split the text file into a list. And then you split that list into its own list, and then you're able to push out the information. And again, this is the kind of thing that you're going to need to think about with formatting documents. Basically, it's like, okay, how do I take this text data file and turn it into an HTML table? Again, you've got to open a table tag, you got to close a table tag. Each row, you got to open a TR, you got to close a TR. Each item, you got to open a TD, you got to close a TD. And remember, nothing magically happens. You actually have to code all of that. And so that's where, especially like with using the split method, it can be very useful because you can split these strings again into lists. Then you can do a 4x loop through the list and encapsulate everything within the HTML tags. and that will be its own fun as you go. We also talked again about file paths, and again using that basic real file path way to get to the file path of where the current script resides, so that you can read files from there or write files. I also showed you that join, and again, remember with the join, why join is so valuable is because it will automatically format the file path based off of your operating system. So if you use, again, an F string to concatenate and actually write out the file path, if you take your script and run it on a Windows server versus a Linux server, it may fail because you're using the wrong slashes or whatever else. So it'll do that file path for you properly. And oh my God, am I done? Oh God, I'm done with this class. I know you might be like, what? You don't understand. I've already done this class. Yesterday, real world. Yesterday, I did this entire class. And then I was so happy. I was like, wow, I got the class done. I felt pretty good with the class. And so I walked up to my camera and I pulled out the SD card. You know what I didn't do first? Stop recording. So I corrupted like an hour and a half of video file. So I had to wake up early this morning to come in and reshoot the entire class I already did yesterday. Welcome to the real world of being a technology professional. Again, precision. You don't have to be smart to be a technology professional. You just got to make sure you actually stop recording before you pull out the damn SD card. Or, yeah, you're going to be redoing a few hours worth of work. So anyways, yay, I'm done. I'm so excited being done right now. Anywho, as always, I enjoy teaching this class. I hope this cleared up a few things for you with files, and I look forward to seeing you at the next one.